So let's go ahead and create some variables and talk about some of the shortcuts. So if I wanted to, I can say integer int total equals 30, and then with a comma I can say int subtotal equals 15, and made a mistake on that previous slide. So I don't want to put in front of it. I just declare the variable up front and I keep working my way down. I could have sworn I could put int here, and it's not going to do that, but I bet you with a semicolon it will let me. That's the difference. There you go. And why does it let me do it with a semicolon? Because remember, it's seeing it as two separate lines right here. So it let me declare it. So it looks like if I want to just declare the same data type here, I can do it with a comma, something like that. Now before I go on, I want to point out that these variables have a scope only to this region right here, and I can prove it. And folks, don't worry about this scope as being very difficult. Once you declare your variables, IntelliSense will tell you whether or not you have access to it based on scope or not. So take a look here. I've got int total and int subtotal. If I come down here, and I've got a variable called today. So let's first of all take a look at today. We saw that today as a variable pops open. There it is. So it sees that today was created. I can prove that that's the case. Let's put two T's here. Come back over here, and there's my TT, and there's my today. So if it pops open, you have access to it. If you can see it, if it comes up in IntelliSense, you have access to it. But watch this. Let's take a look at int total here. Notice that int total does not come up in IntelliSense. As far as this program is concerned, int total does not exist at all. Okay, not at all, because it was declared up here. So and how do I know where the life of these variables are? There's the opening bracket immediately above it, and there's the closing bracket. So those variables only are alive when that program code right there is running. When that last bracket is hit, that variable ceases to exist entirely. Let's talk a little bit about user-defined constants. Although I'm going to tell you, as a Windows developer, I don't use a lot of user-defined constants. First of all, let's talk about what it is, and then we'll talk about other ways to do the same thing. So a user-defined constant is a value assigned name, kind of like a variable, but it's defined by the programmer. But once you create that variable, you cannot go back in and change that variable. Constants maintain the same scope as variables do. Okay, which means that where you declare that constant only has life, but generally you're going to find that if you're going to build a constant, you're going to put it as a class level variable at the top. I can't imagine why you would want to put a constant within a method, but I suppose you could if you want to. An example might be a string reference to an image used throughout the project that was created to save effort in typing or to provide a focal spot to edit. So you might want to go back in there and save a location of a particular image so that later you can just call that string up and find out where that image is located. Another example of a user-defined constant might be your company might have a setting at the top, maybe minimum wage, and you want to put a user-defined constant for minimum wage in. And the reason you do it as a user-defined constant is later, if one of your co-programmers decided to change that variable, it would generate an error telling them that you cannot change a user-defined constant once it's been assigned. So how do you do a constant? And we're going to talk again about better ways to do it than constants. But you start off with a const word, and then after that you just start with your standard declaration. So from this point forward, string constr version, that is our standard declaration we would use right there normally. But I put the const in front of it. Now notice what's happened here. Not only am I declaring the variable as a constant, but I'm assigning a value to it. I have to do it this way. If I simply did what I can do with a variable and did, constant string conversion semicolon, and then down on the next line try to do constr version equals 1.28, I'd get an error because it would tell me that once you declare a variable, you cannot reassign a value. So, a constant. So once the constant, when you declare a constant, you not only have to declare it, but on the same line you have to give it an initial value. So let's take a look at that in an example here. Okay, so if I came up at the top and I wanted today's date, let's correct this. I wanted today's date to be a constant. All I got to do is put a const in front of it, and now it becomes a constant. Let's see what the error is. Date times can't be constants. So let's come back in here and let's do something like int min wage equals, and I have to do the equal. We'll take a look at that in a second. So I want to do a constant int data type minimum wage equals, let's set it at $12. It's got to be set at 12, like that. Okay, now that's a global scope. If I come down here and I do int minimum wage, you'll see it exists everywhere within the program because it was defined as a class level variable. But let me show you one other thing here. If I come back in here and I decided I want to change this and do it like a variable. So here, I declare the constant, right? Now, it's not going to let me do it anyway because it's going to tell me that when you declare a constant, you have to give a value. So I had to initially do it, but you cannot get away with doing something like this. And the reason it won't let you do it is because that constant has to have an initial value. So look at this. Watch this. Here's another error I can generate. I'll give it an initial value of 0. Okay. And now you're going to find out over here that I cannot assign int minimum wage 12 because it's already been assigned. It's going to give you that error here. There's already been assigned as 0. So it all has to be done on the same line. Now before I go on, I don't use constants any longer. Visual Studio has created a better way of doing constants, and what they do is they have a thing up here that are called settings or resources. If I double click on settings here, what I can do in this setting is I can set up any kind of variable that I want, and this basically becomes a constant in here. I can come back in here and say I want to create, let's see what we did over here. I've got one called we created one called int minimum wage. So what I would do over here is I would create a integer. Okay. Now I get to decide when I create this, does this follow the user or does it follow the application? What does that mean? That means then that if I install it on a computer, does this, because I can actually, there's a way I can change these values, even though I'm going to treat them as constants. It wants to know, does the user going to see different values than the application? What does that mean? That means that this is actually saved with the program when you stop. So if I came back in here and I said that my first variable will be int minimum wage here, and I set int minimum wage to 12. Okay, now the computer is going to maintain that, and although I can change int minimum wage in the program, it's always going to retain that value for me. Where is this going to be important to you? Well, let's say that you were writing a game and you want to store the high and the low score of the game. You could use this to score that. So as the user gets the new high score, you reset, and we're going to not do that in this class. I'm just going to talk about it. You could reset the high score to the new high score, and then when you quit the program, it will retain that, and when you load it back up, you load the previous high score back into memory. So there's a lot of great places for it. So my point being is you can use constants, but the likelihood of you using a constant as a quality developer is going to probably be minimal. Now let's jump into the elephant in the room, if you will, and that is casting. And this is probably the most difficult, and I don't want to say difficult because it's not difficult, it's very simple. But this is probably the area where students have the most confusion when we're dealing with variables. And this is an area where BASIC didn't care. C# says if I'm going to move a number into a string, I've got to convert that number into a string before I move it. Or if I'm going to use a string that has a number in it and I want to move that into an integer, I have to convert it before I move it into that integer. So typecasting, or sometimes we just refer to that as casting, is the conversion from one data type to another. So Unlike languages like Visual Basic, C# is going to require that both sides of an assignment statement be of the same data type. Means that you can only put an integer into an integer, you can only put a double into a double, a string into a string. That's about all you can do. So let's continue on here. If you don't test carefully, this is a source of a lot of frustration and a lot of logic errors, because this is where we can lose some accuracy in our data. There are a couple of areas where we can make mistakes, and I will point those out a little bit later. So there's three different ways that we can cast, that we need to understand, three different methods of casting numbers. We're going to do a number to a string to a number, or one type of number to another type of number. Okay, let's take a look at all three of those, and this is something you really want to work on this, because this is where, of all the areas, you're going to have your initial challenge is in the casting. But the great part about this, folks, is that Visual Studio, when you write an application, will not let you cast, will not let you assign a value unless they're of the same data type, and we're going to take a look at that here in a second. So initially, let's talk about how we cast from a number to a string. We've already done that before, but we're going to go back and revisit that. So why would I want to cast from a number into a string? Well, maybe I've done a formula and I want to put that answer back into a label on the screen. If I'm going to display an answer back to the user, odds are that I'm going to put it into a label, and a label is always of type string. So, and these are one of the easiest ones. Anytime you want to take a number and you want to convert it into a string, all you have to use is the toString method. So if you look at the screen here, you'll see that I've got this variable called int employee count, and it's equal to 33. Okay, so I want to now move that into a label that exists on my form. If I try to simply move it, and let's say I didn't have this period toString at the end, it's going to give me an error and telling me you cannot move an integer into a string property. So what I have to do is I have to make sure the right side of the equal sign matches that left side of the equal sign before I move it across, and all I have to do is use a toString method. So int employee count dot toString will convert this number into a string before it moves it to the left. Now let's talk. In fact, let's jump back over and take a look at an example of this. As long as I'm at it, let's see how that works out. Let's open our application up here. Let me jump out of where we were before. I don't want to save that. And what I'd like to do now is let's come back over here, and I'm going to throw a label here on the screen. And this time I'm going to take that label and I'm going to call that label output. I'm going to give it a proper name, LBL output. And I should start naming all my objects, because I'm going to tell you, when you turn assignments into me in the Windows world, I do not want you to include, I want every object that's going to be accessed, that's going to be addressed by your program, to have a proper name on it. So you're not going to use textbox 1, you're not going to use textbox 2 or label 1 or checkbox 1 or button 1. You're going to give them meaningful names, and those are the names that you're going to use when you write your program. So in this case, I'm changing the name of that label from label 1 to label output. So I'm going to click outside of it, and notice that it didn't change. How come it didn't change this? It didn't change it because I changed the name. Oh, wait a minute here. I did the wrong one here. I need to go to the name property at the top and change that. Let me do it. Let me get out and do a Control Z and get back to where I was before. There we go. So let's come back in here and do it the right way. So I'm going to go to the name property up here. I'm going to call this label output. Okay. Now when I click out of it, notice that it left that label 1 in there anyway. Why, if I changed it to label output, did it leave label 1? It's because when I drug it on, it gave it the default name of label 1 and the default text of label 1. So if I want to change that label 1 text, I'll come down here and I need to put something in here. So for right now, I'm just going to put the word empty in. Okay. So now I've got empty over here. So what I'd like to do now is I simply want to put a number into that label. We're going to keep it really simple right now. So let's get rid of this. In fact, I'll keep this right here. And what I'd like to do is I want to move int total, that 30, into that label. right here. Okay? So the name of that object is label output. That's the destination. So I always start off with my destination. Where do I want the answer to go? Do I want to go to a variable? Always the left side of the equal sign is the destination. So in this case, I'm going to do a label, and label output popped right open. I go dot text is equal to, is equal to, and then I'm going to go ahead and type in int total. And now I'm going to generate an error here. And let's take a look at why. And I'm going to get rid of this code down here as long as I'm at it. And notice that it's going to tell me when I highlight it, I'm sorry, you can't go from an integer into a string. So the important part, folks, is this is one of those areas you don't make an easy mistake. The screen's going to tell you, and I can't run this either. If I run it, it's going to say it can't be compiled as long as I have a syntax error, which this is. It's saying this is just not going to work. So for this to work, I've got to do a dot toString on the end of it. And toString is a method of the integer object. So as soon as I do a toString and I close it out, now all of a sudden it's going to take this integer, it's going to convert it into a string, which is what text is, okay, and it's going to move it right across. Notice when I highlight text, it tells me that it's of a type string. Notice when I do an integer here, I highlight the variable, it tells me it's of type int. Now when I run this button, I would expect 30 when I click the button to appear in that label right there. And there you go. That plug 30 in. So moving from a number, and it doesn't matter whether it's a double or not. Let's try this one. Let's do a double salary. Okay. And double salary is going to be equal to, I want it to be equal to $3,000.98. Okay. So now I want to move salary over in this label. That's all I got to do is just simply put salary here. Let's just do the whole long way. If I did salary by itself, okay, type that in there, semicolon, it's going to say, can't do that, can't go from type double, read it here, to a type string. So I need to cast it. I need to convert it into the correct data type. Oops. Try that again. And the moment that I do that, got an extra semicolon in there, and I run it, and I click the button, I now get the number that I typed in. See how that worked? So that's casting from a number into a string. Would have done the same thing had a string variable as well. Let me show you something else here. Let's say that I defined a string, and I call this string str total. Okay, that string is, because it's of type string, is going to act no different than its text property. And if I come down here and I say, okay, I've got str total here, okay, and I make that equal to salary, I'm going to have that same error I had before. Oops. Same error I had before. And that's going to tell me right here, it's saying you can't do that because salaries are type double and you're moving it into a string. These are both of type string right here. Any text property is going to type string. And think about the concept text tells you it's string. So in order to move salary into str total, I'd have to do a toString. My IntelliSense here. I do toString. And now it will work. No errors. Okay. So now we've taken a look at how to go from a number into a string. Now let's take a look at going. Now what we're talking about is putting a formula in. The same thing holds true for a formula, folks. This is an important one here. So let's jump back over here. What if I wanted to say take the salary times 10 and move it into str total? Okay, so if I did this times 10, I'm going to get an, oops, let's try that again, times 10, I'm going to get an error. And the reason is because the way that your editor looks at this is it thinks that you're trying to do a 10 to a string and you're trying to multiply that times salary, when it looks and says, wait a minute, that's just not going to work at all, because you can't, because if it did 10 the first thing it would do is it would convert that to a string 10 and try to multiply a numeric salary times it. So the way that we do this, folks, is anytime we have a formula, we want to put the parentheses around the entire formula here. And the formula will also have a two-string method. So in this case, what I'm telling it to do is do this mathematical operation, and I have to put in parentheses. So do the entire mathematical operation, come back with an answer, and then take whatever answer and do a two-string on that at the very end. Okay. So, and another way, if you don't like doing it that way, what some developers will do, and it's not wrong, is they'll come back out here, they'll create another variable, do the formula to the variable, and just have a single variable here, two-string. So for example, you might do something like big total, and I'll do it on one line, is equal to salary times 10. Okay, that's going to work right there. Okay, I'm taking the salary right here times 10, I'm moving that into big total. So there's a formula here. That data type already matches double, so I'm not going to get a casting error. How do I know that? Well, because whatever this part here is, salary is already of type double. And the way the formula works, by the way, folks, is whatever the most accurate part of the formula is, that's how the answer is going to come back. So if I do an integer times an integer, I'm going to get an integer back. But if I do a double times an integer, I'm always going to get back the most precise portion of that formula, which is a double. So that's why this allowed it to work right here. Even though that was an integer right here, it will let it work in that formula. And if you're not sure, put the formula in. The worst that's going to happen is give you back an error. Okay. And this example right here then would change. I would then get rid of this and do a double big total here. And it does the same thing. Which is the better method? It's up to you. I don't care which method you use. What I care about is by the time it gets to this point, does it have the correct answer? That's the most important part, at least at this level. We'll work on efficiency as time goes on. So that two-string method that I just looked at is a really, really cool method. It does a lot more than what I just showed you when we're dealing with numbers. We have this two-string method, and it can take some parameters inside those parentheses, and it lets me format my data the way I want it to look. So we're going to take a look at the two-string method that exists in every numeric variable. We're also going to look at this thing called string.format, and that's a really cool feature of the string. So before I go on, let's talk about the two-string method. The two-string method by default just converts whatever that numeric variable is to a string. But in the process of doing that, I can add parameters, that's these guys right here on the left, in between these parentheses. And when I do that, what ends up happening is it's going to format that data to be whatever that format says. So if I do a standard C, that's going to format whatever I pass in. It's still a string. This output's still going to be a string, but it's going to put a $sign in front of it. And if there's enough characters in it, it will also include a comma in there to separate out the thousands, millions, etc. By default, currency has 2 decimal places, but there is this hidden opportunity I have over here after the C. If I put a C0 in, then I'm telling it I want whole dollars and no decimal places. So that N represents the number of decimal places. C2 and C are the same thing. C defaults to C2 anyway, but if I did a C3, I'd end up with an answer that comes back with 3 places. A P is a percentage. So it's going to convert an answer that we have back into a percentage and include the percent symbol at the end. So if I have like 0.75 and I pass a 2-string with a P in it, it's going to give me 75%. With 2 decimal places. If I want to control the decimal places, just like with the C, I can then control it with a 0 at the end. And I could come up with an integer. P would just give me a whole percentage. And if I want to use an N here, N is very similar to currency. It just doesn't put the $sign in front of it. But it does put commas in and formats it with commas and allows me to have decimal places. So it's a pretty cool features. Let's take a look at an example here that we were working on. So when I dealt with salary before, let me get rid of this stuff down below here. When I dealt with salary, and this is telling me this is not being used, Okay, I wanted to plug salary back in that label output. So let's refresh our memory of what this looks like when I click that button. So when I click the button, boom, it put, you didn't do anything. Oh yeah, I did. It put salary right here, okay, in my label. So it took that 300.98 and stuck it right, or excuse me, 3000.98 and it stuck it right there in that label. Now what I'd like it to do is format it as currency. So within these quotation marks in here, I'm just simply going to put a C. That's all I got to do. And I'm going to rerun this application again. Boom. Okay. Click hello. And now notice that it's applying a $sign and a comma after it. Really cool formatting. And if I change this and said, you know what, I'd really like to have 0 decimal places. Now notice my number is 3000. Let's see what ends up happening now. Question is, will it round it with 0 decimal places or will it truncate it? Will it give me 3000 or 3001? It rounded it. Notice what it did is when I converted this to 0 decimal places, it rounded it up to $3,001. And it does a standard rounding rule. Standard rounding rule would be something like, I believe, let's try this, 0.4, let's run it. And I still get to 3,000 because it only rounds 5 up, 4 down. Now, let's come back out here and let's put in rate. So I want to create one I call rate, and I'm going to set my rate at 0.76532. And now what I want to do is I want to format rate here as a percentage. So let's just do a standard percentage here, a P, and see what it does. Click it, and it takes it to 76.53. So it gave me automatically 2 decimal places within that percent. They all default to 2 decimal places, by the way. The currency does as well. But if I wanted to go to 1 decimal place here, and I rerun this guy, boom, I get 1 decimal place. So that 2-string method is really, really cool. It does a lot of neat stuff for us. And let's take a look at N here, just for the heck of it. So I want to do an N3. Okay, what I will end up with is at this point, I should get 0.765 back, I would expect, because it rounds it. And that's exactly 0.765 was returned back. Okay, so the point being in this is how valuable this formatting is. It only belongs to the 2-string method right now. Now, there's another one that I want you to understand, and that is the string dot format. This is a little bit different from variables. What this does is this allows me to go back in and format values. So let's take a look at what this is. I've got the string object, but it has a format method in here, and the format method takes arguments. The first argument it takes is a string of information that you want. And notice these little guys in here, this bracket 0, bracket 1 in here. Those are placeholders. So anything that's not a placeholder will be printed out verbatim. Notice December sales, boom, 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 hyphen annual sales. Okay, that's all going to be printed out verbatim. But what happens is inside here, I've got a 0 and a 1. What I can do is after this string, I can pass it the values that are going to be passed in, and what it's going to do is it's going to move double sales into where the 0 is and double annual sales into the 1. How does it know? Because it's the first oops, let's go back again. This is the 0th item, because remember, we're geeks and we start counting at 0, and this is the first item. So this will replace here, and this replaces here, and what you would end up with is output perhaps that looks something like this right here. And this even gets a little bit more powerful. This is a nice way of formatting output. We're going to take a look at concatenation. That's another way of doing it, but this is the cleaner way to do it right here. Now, not only can I put the 0 and the 1 in, but if you take a look at this example here, after the 0 I can put a colon, and I can now put the formatting in that I did in that 2-string method before. So here it says put that first item in double sales, but format it as currency with 2 decimal places. Or this guy says, and this is not a good example because it's certainly not a percent here, but this guy would say over here, take and format item 1 as a percent with 1 decimal place. So what I've done is I've gone back to this previous example, and I put in my 0 and I put the C in for both of these guys, and now I end up with formatted output, just like that. Okay, let's jump back and take a look at an example of this one here. So what I want in this output is I've got my rate here, and down here let's do double income. Something like this, and let's set it equal to 5,000 right here. Okay, now what I want to do is I want to format my output in this label output to be a little bit neater. I don't want to use this output. So what I'm going to do is I'm going to delete this guy out. I'm going to type in string here, and I'm going to type in dot format, and you'll see the format pops up. I'm going to put in my close parentheses. Now what I'd like to do is I want it to say, so I'm just going to write the whole thing out. The rate of this percent, XX percent, I'm just going to put holders in right now, for, and I'm going to put in here my income. So I'll put income right here. So that's what I really like the format to look like. So the way to make this work is I'm going to take where I want the first number to go, the rate, and I'm going to put a curly bracket in here. I'm going to put a 0 in on that, just like that. Then where the rest of this is going to go, I'm going to come back over here, and I'm going to put another curly bracket. I'm going to put my first piece of data in here, and I'm going to close the string out, just like that. Now I'm going to come back in. I want to put a comma in here, and I need to put the data that's going to match that first piece in. So the rate is going to be rate. So I'll just type in rate. I should have used Hungarian notation. I didn't. Okay, so let's change that around. I want this one to be double rate. Okay, and then down here I'll change the same thing. I need to be consistent in how I put them in. So I got double rate here. I'm going to put another comma in here, and now I'm going to put in double income here, like that, and I need to close a semicolon out at the end of the line. And let's go back in and see what happens when I click that button. I would expect in that output, and let's take this label so I got enough room and move it to the left here because I need a little bit more territory when it prints out. Okay, I would expect it to plug in there the rate of whatever double rate is for blah blah. Not more creative, but let's see what happens. So let's run it. Click hello. The rate of 0.0724 for 5,000. And in fact, let's go even a step further. Check this out. Is, and let's put a number 2 in here. Let's get fancy. Okay. What I want to do at the end of this guy here is I want to put in double income times double rate. Double income times, that's the shift 8 asterisk, double income, like that. So I now got 3 different arguments, and for every number here I have to have an argument. So that's the first one, the second one, and the third. Let's run this and see what it looks like. Okay, click hello, and it says the rate of blah 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 for 5,000 is, and here's the answer. Multiplied it times, multiplying it out. And did I use the right one? I did double rate. I did it backwards. Look at, I did income times income. How come nobody told me about that when I was typing it in just now? So let's do rate here. So we're going to find out what is 76.5% of 5,000. Run it, click the button, and there we go. But I want that to be formatted a little bit prettier. Okay, I'd really like it to look prettier. So I'm going to take this 0 here. I'm going to put a P1 after it. I want a percentage 1. I want that to simply be 76.5%. And then for this 1 here, I want both of these just to be currency. Just a standard currency with 2 decimal places. And let's rerun this. Okay, click hello. And there you go. The rate of 76.5% for $5,000 is $3,826.60. Pretty slick on how easy that was. I could have done this using what we call concatenation, but it would have been a lot harder. Concatenation is a formula, so I could have done this. I could have gone back in, the long way, the harder way, the old way, if you will, and said something like this. Label output is equal to, and then I would say the rate of, okay, then right after that, I would have typed in, I would have added in after the space, the double rate, but I have to make it a string because it's a number. So in this case, the example I gave before didn't require me to do any of this string stuff, but here I have to do a toString. Okay, so I do my toString here. And then after that, I want to say, I want to add into that now a space, the word for, and a space. Why do I do that? Because that represents this stuff right there. Okay, the next thing I want to plug into that is double income. So I have to do the same thing, plus double income, and I have to toString that as well, dot toString. Okay, then I want it to say plus, and I need it to say is, so I add in a space, is, and a space. Those are literals. And then after that, I want it to plug in the formula. So now I take that formula right here, copy it down here, but I have to, because it's a formula, I have to surround parentheses around the whole thing. And then I do a dot toString on the end of that. And it's a method, and I close it out. Now, let's take a look and see. I'm going to comment this guy out right here. ToWax is a comment that tells it to ignore that line. And let's see what this line looks like. Click it. And it looks like the very first example that I put in. But I need to format it. So how could I format that? Now I need to go back here, and this is going to be a P1 here. P2, and this is going to pose me a problem here. This one will be a C, a currency. And this 2 will be a currency. And I don't believe case matters in this. So now let's go back in and let's rerun this guy. Click it. And now it's printing out, but you take a look at these, folks. Let me come back and get a little bit more territory here. You ask yourself, which one makes a little bit more sense? It's easier to read this top one than it is the bottom one. But they do, from here across, does exactly the same thing from here across does. Okay? It's your call which one you want to use, and I really don't care which one as long as the output comes. I'm going to tell you that I'm going to focus on this top one. I think the top one is a little bit easier myself to work on. Okay, now let's talk about going from a string to a number, and this is the one that's a little bit more involved. So why would we want to go to a string to a number? Well, let's say we've got a text box and I want to add two numbers that exist in a text box together. So let's go back to our example here. And while I'm here, I want to show you something. I want to get rid of some event handlers. I want to get rid of this event handler right here, perhaps. Okay, I really don't, but I want to show you what happens when I get rid of it. If I delete this event handler right here, I'm going to get an error. And the reason is because when I created the event handler was saved in the code behind, and it created this method for me, and the code behind says, go into your code and find textbox1.leave, and that's what your leave event is. Well, by me deleting this out, I'm deleting the code, but what you're going to find out is, and I'm going to get an error here, is I did not delete the event handler that went along with it. So there's a couple of ways that I can do that. Okay, the easiest way I think to do it is to delete the event handler out, just like I did, generate an error like you see here, and come down to this first error. And notice what the error says. It says it does not contain a definition for textbox1.leave. It's telling me the code behind that generated code thinks it's there, but it's not there. So I need to get rid of it in that code behind, that code that I told you normally you don't want to touch, but in this case you do. So if I double click this error, boom, boom, right here, it's going to take me to the code behind, and see that light bulb right there? It's telling me that's where my error is at. This is the line that says go look for that event that no longer exists. The way you correct it is highlight that whole line right here and just delete that line out. Boom. Okay, now as soon as I delete it and I close this out, I now can go back to my form, and my form is working. So what I want to do now, folks, in my program is let's go ahead and I'm going to do a little bit of changes here. Okay, I'm going to come back and I'm going to change some names around. First thing is I want that to go back to a single line input box. I don't want it to be multi-line. So I'm going to come back to my multi-line property, and I have the text box selected, and I do multi-line, and I just double click it, or I can hit the down and I turn false, and you'll see it comes back to a text box. Okay, now I want to put another text box in. I could just simply grab a text box and drag it in, or I can take that text box, do a Control-C, copy it, and then do a Control-V and paste another text box in. I'm going to get rid of this checkbox here as long as we're at it. I'm going to use this guy, and what I want my program to do now is I want to put two numbers in. I want to multiply those numbers together, and when I click this button right here, I want to put the answer here. Okay, so let's go back and take a look at that. In order for that to work, what I need to do is, let's get rid of all this code right here. I need to read that number, and I need to read that text box, but I need to read the number that's going to be stored in that text box. Okay, so let's take a look at how to do that. Okay, so first thing I'm going to do is I'm going to put that into a variable. I want to read that into a variable. So I want that to happen when this button is clicked right here. So first thing I'm going to do is create a variable. Oh, in fact, let's go back here. First thing I'm going to do is name these guys. Make this a little bit more meaningful here. Okay, so I've got this text box 1. I'm going to call this text num1. Okay, and I'm going to call this one, the second one, text num2. Just like that. Okay, I've got my label output already. I'm going to change the caption on this button. I want that button to be named button BTN total. Giving it a name. Okay, and then on that button I'm simply going to put the word calculate. Calculate. Just like that, except I better spell calculate right. Okay, so I've got calculate on. So when there are numbers in here and I click this button, I want the total to show up here. Okay, so let's go back in to our calculate button here, and let's put the code in to do that. So first of all, what you would think you might want to do is something like this. You might want to do the incorrect way, which is label output dot text. Remember, we always have to do the dot text. That's going to be a very common thing for students' errors, is you're going to forget to put the dot text on it, because that's what makes the answer show up in that label. So the text box is going to be equal to this text num1, what's in it. So let's do that. Text num1 dot text times, I'm going to do the dot text times text num2 dot text. Okay, and you'll notice immediately when I do that, it's going to give me an error. It's going to say, whoa, 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 wait a minute. You cannot multiply a string times a string. Both of these are strings. You cannot multiply a string times a string. That doesn't work. So what do? The problem with it is I have to make this guy become a number, and I have to make this guy become a number as well. So the first thing I have to decide on is, what kind of number do I want him to be? What do I want my answer to look like? Do I want my answer to have decimal points on it, or do I want my answer to be whole integers? And it really is going to depend upon what I'm going to want the users to type in here. If I want them to type decimal points in here, I can't set it up as an integer because I'm going to get an error right away. So what I would have to do is, I really want my answer probably to come out as a double precision. I want it to come out with a decimal point in it. Later, I'll show you how to force integers, but right now, let's assume that they're going to be double, which means then that I have to convert that into a double number and multiply it times that converted into a double number. It's very simple, folks. What you start off with is the data type you want that text box, or that string, if you will, because it could be a string as well, to become. And I want it to become a double. Okay, so you start off with that keyword double. That's what I want it to become. Then I hit a period. The key word that I'm looking for that says convert, I wish it was called double dot convert. It's not. It's called double dot parse. So as soon as I hit the P key, you're going to see parse pops open, and parse tells me over there that there's 3 different ways to use it. There's 3 overload methods. Really, all I want to do is parse that into a double. So that's all I have to do is separate and surround that guy right there with the parse. Now, from that point on now, this guy now that will return back whatever in that text box as a double precision number. Okay? I need to do the same thing with this guy over here before they're multiplied. I can't, a lot of students are going to want to do something like this. They're going to want to say, okay, let's multiply those text boxes together and then parse it. Can't do that. Why? Because you're still multiplying the text times the text. You have to convert each one of these guys individually. So that's what I'm going to do right here. I'm going to convert that one, and then I'm simply, because I'm a lazy typist, going to grab that, paste it right here in front of this guy, and close it out over here. And notice my errors. Oh, my errors don't go away. What's happening here? Yeah, let's think this through. So what I've ended up with is I said take what's in the text box 1, convert it into a number, and multiply it times what's in that other text box and convert it to a number. So my answer that comes out right here is going to be a number. Well, I got a problem because I'm moving it back into a text property. So I have to do what I showed you before. I have to tell it, do the math first. I'm going to put it all in parentheses. Say, do all that math first. Then when you're done doing the math, then do your two-string method over here, just like that. See how that works out? Now let's go back out and let's run this and see what it's going to look like. Okay, click this. I'm going to put in, it wouldn't matter whether I put an integer or a double in because they're all going to be converted to double anywhere. So let's say I want 4 times 5 and click calculate. Uh-oh, 4 times 5 isn't 16. Uh-oh, what did I do wrong? I can see it right now. Anybody catch my error? Look at this. I multiplied text box 1 times text box 1. Let's make that a 2. Okay, let's rerun it again. See what happens. Boom. Now let's put in 5 and 6 and hit calculate. 6 times 5 is 30. So it worked. Worked just fine out there. So what I had to do is I had to parse these out. Now let me show you. This will work really good. You saw me if I put in 55.7 and I put in 22.5 and I calculate it. There they are multiplied together. Works great. Let me show you where a possibility of an error comes up though. Let's decide that I want to do integers. Okay, so I can do that. Let's say that it's assuming that those numbers only have integers in them. So let's convert these back to integers over here. Int.parse. Okay, let's rerun it. And let's put our numbers in here. So let's put 3 times 7, calculate, came out 21. Worked great. But now let me show you where the issue comes in. Because I told it to parse whatever was in this text box as an integer. Let's put in 3.7, 7.4, calculate. I get an error. And why do I get an error? It's going to tell me that the input string was not in the right format. This is basically what's called a logic error. It didn't keep me from running the program, but it says as the program is running, you told me to convert this 3.7 as you see on the screen here into an integer, but it's not an integer already. I can only convert what is an integer into an integer. So this is going to cause a problem for me in the conversion because, again, I cannot convert a 3.7 to an integer, nor can I convert a 7.4 into an integer. That's the error. But if I do put pure integers in there, so let's go back in and take a look. But pure integers, it doesn't matter. They'll work, okay? But the challenge is the moment you introduce any decimal, boom, any decimal to any one of these, that's when it's going to puke. Okay. Later, we're going to talk about how we can prevent those kind of errors from happening, or if we don't prevent it, how we trap those errors when they come up. It's called error trapping. Let me stop this program right here, Let's jump back to our PowerPoint slides. So you'll see in here to cast from a string to a numeric value, you're going to do an int.parse. And it doesn't have to be just a text box.text. I could have created a string and put a 55 or a character 55 in that string and parse that string to the numeric 55 as well. Okay, but what you're going to get is you're going to get errors if you don't do it right. That's the beauty behind this. This is one of those error areas where it's not a big deal because the browser is going to tell you, not the browser, but your editor is going to tell you that you can't do what you're doing. Just you saw that happen before. So this one is one that's going to allow me to cast. In this case, I'm casting the sales to a double, and then I'm going to double that times 5.05. Now, if I wanted that to go back in, though, once it's done, into an existing label or a text box, most likely a label because text boxes are for input and labels for output, then what I would do is I would take that entire formula, surround it with parentheses like you see here, and do a toString on it at the end. And if you're not sure, if you put it in without the toString, it's going to tell you can't go from a number, or in this case a double precision, into a string. That's the first thing that tells you have to toString that method. Now, let's talk about the very last one that we come up with, and that is casting a number to a number. And you're going to say, well, that just sounds strange. Why would you have to do that? And the reason they do that is to protect you. Because if I take a double precision number, maybe a number like 1.75, and I was using basic language, and I cast that into an integer, I would lose all my decimal points, and I wouldn't realize that. I would lose accuracy. That would cause a major problem. So C# says, look, even though I'm a rule, I'm going to help prevent that from happening. I'm not going to let you cast from a number. I'm not going to let you move a value into a number that's not ready for it. So let's just take a look at an example of this right off the bat. Okay, so I can use the same example here. I'm just going to put it down below. Let's say I create a double variable. So I've got a double, let's start with integer. I've got an int, and I'm going to call mine subtotal. Okay, and I'm going to create another one. I'm going to call it double, and let's be consistent here. Let's call this one int subtotal, and let's call this one double subtotal. And let's play around with that a little bit. Let's put in here in the int subtotal what I want to do. Let's put a value in the double subtotal. Let's put in $33.56 right here. Now what I'd like to do is move that 33.56 into this integer variable. So the way you would normally do it is you put the destination first, int subtotal, okay, is equal to double subtotal. Okay, just like that, and I close it out. And notice right off the bat it's going to give me an error. And let's see what the error reads. It says you cannot complicitly convert a double to an integer. Are you missing a cast? So here's the problem. By me moving 33.56 into an integer, I'm telling it that I don't want that 0.56 anymore. And what C# says is you need to tell me that's okay. You need to tell me specifically it's okay to get rid of that 0.56. Now, so we've got the toString method we looked at that converts a number to a string. We looked at the parse, which converts a string into a number. Now what we're going to take a look at is a different way. It's called a pass-through method. The pass-through method. And what the pass-through method says is that I want to okay this. I want to okay this going through. So what I need to do right after the equal sign is in parentheses, I'm going to tell it what I want the new data type to be. int, right here. And notice that when I do the int, the error goes away. And by me doing this, I'm telling it, it's called a pass-through. I'm telling it, when you take this double total and you're moving it over here, pass through this integer parentheses here and convert it into an integer first. It's okay. I'm telling it it's okay to lose that accuracy. Let's take a look at that in action here. And I'm going to comment this line out. Let's see here. Okay. So click the button here, and this line hasn't run yet. So what I've got now is I'm trying to move 33.56 into this integer variable. And this line will allow it. So I'm telling it that 56 is not significant to me. So let's watch what happens when I pass that line. Now let's point to int subtotal and see what the value is. Look at that. I lost the 0.56. It didn't round either. There was no rounding. It just truncated everything at the end. Now later, if I am worried about rounding, I'm going to use, and we'll talk later about it, a math round command. I'll round this first, then convert it. But this allows me to pass that number through. And it's very common between when you're going from a double to an integer. But let me show you something here. And I don't want to confuse you, so bear with me very carefully here. Now what I want to do is I want to go the other direction. Let's take this guy out. Now what I'd like to do is I want to move into this integer right here, and I want to put the value 33 in here. And I want to go the opposite direction this time. What I'd like to do is I want to move that integer into double subtotal. So I'll start off with double subtotal is equal to, and then I'm going to type in int, my int subtotal right here. And I'm going to do my semicolon at the end. Well, wait a minute. Notice there's no error here. Why do you suppose that there's no error? And the reason is that there's no error is I'm not losing anything at all. So I don't have to cast an integer to go to a double. And the reason is because 33 and 33.00, which it's going to convert to in a double, are the same exact number. But if I went the opposite direction, where I'm going into an integer, I'm losing accuracy, so I have to cast. It's not going to force me to cast an integer, but I'm going to tell you something, folks. I would highly recommend you don't worry about trying to remember when. I'm still, in my case, I'll always try to remember to go back in and still recast it again. It's not required to do this, except I put the underline there. It's not required to do it, but it makes more sense. I mean, there's that consistency behind it that says, you know, when I move from one data type, pass it through and convert it to a double. Not required, but it's probably a good habit to get into. Good habit because it's a consistency. Would I require it as an instructor grading your papers? Absolutely not. What I'm worried about is, does it work? Does it work? Okay. So again, you do not have to cast when you move a data type to a more precise, or you do not have to cast when you move data from a numeric data type to a more precise data type. And a double is more precise than an integer is, so I don't have to do it, but I would recommend you do it anyway. Okay. Now, let's talk real briefly. We're not going to spend a lot of time on this because we're going to visit this later because there's some new commands I have to learn to make arrays a little bit more valuable. But let's say that we have a screen and we want the user to put values in, and I don't know whether or not he's going to put in one value, he's going to put 100 values in, but I need to have the ability to store those values. So what I don't want to have to do is say, well, you know what? He may put 100 values in, so I'm going to go out and declare variables, 100 different variables for that. That would be ridiculous, folks. That's very, very time consuming. And if you declared 100 variables and you only use one, look how much memory you're wasting. You're wasting 99 variables that were set up. So in most all programming languages, there is the ability to use what we call an array. And an array, and I'm going to be very simple on this one, array is simply a storage location that allows us to go back in and store multiple values in a single entity, or basically a single variable. So we'll create a variable that points to an array. So here's an example of an array that I might want to store 8 different names, 0 through 7. And unfortunately, we're 0 based in this. So the 0th item is the first item, the number 1 item is the second item, Dave is the second name, even though he's at location number 1 in here. So this is the storage mechanism we're going to use, where we can store a value in, and I can say, go back out and grab the 4th name in the list, and it's going to pull up Scott, if you will. Or grab the 0, or the first item, the 0th item, and it's going to pull up Lynn. So how do you declare a variable? Okay. Variables are very simple objects to create, although I'm going to tell you here by the time we get to the end of this lecture, you probably are not going to want to use a variable, because what's happened is Microsoft has taken a variable and they've made it into a really cool object that we can use called a list that does everything, an array. It does everything an array does, but it does a lot more and it does it a lot easier. So first of all, let's take a look at the screen here. If I want to declare a variable that I'm going to store 0 or more names in, it's obviously going to be more than 0, I'm going to declare a variable like you see in this top string here. And that's going to leave an open-ended variable out there where I can just simply add, as I add a new name in, it's going to increase that the access to that name. If I know that I only want to store a maximum of 100 names, then in between these square brackets I could put 100 in. And if that's the case, when I store the 101st name in, it's going to generate an error called a input past end, or a subscript out of range, which tells me that you're trying to put in a name into a container that doesn't allow that many names. So that's one method I can use to create a variable, in this case, an array, and this array is called, it has an array variable name of names. Now, this method down below, right here, will allow me to create the variable, a names variable pointing to an array of string, okay, an array of strings, and at the same time, within these curly brackets, it allows me to put in the names. And I've only got a subset of the names down here, but I could have put all the way down to Dorothy in here had I wanted to. So that's one way to put them in. Or if I wanted to, I can go to a specific index and say I want names location 1, which is over here, to be equal to Dave, and it will then go back in and at that location plug Dave into that array location. And later, if I want to know what's in array location 1, the second item, I can refer to names in that square bracket 1 here, and that's going to return back to me Dave. Now, I'm not going to spend much time on that, because really what I'd like to do is expand on this array, because we're going to use lists instead. But before I go on, arrays, as far as we're concerned, will only hold one piece of data, and when you create an array, you need to tell it what kind of data is going to be held in that array. So if I wanted to have an array of integers, it would be int with the square brackets and a number if I wanted to specify the dimensions inside of it, and then the name of the array on the side. So I can create an array. I can create an array of any data type that exists out there that I would like. But let's not focus on arrays. What I'd rather do is jump you over here and have you take a look at lists. Now, lists are very similar to arrays, but lists will do things that arrays can't do. What they did is they took an array and they added a whole bunch of programming features to that array, and they created it as an object, and they call it a list. So if I wanted to sort an array, it's a pain in the butt to sort an array. I'd have to write this routine that says, okay, grab the first item, look at the next item. Is the next item less than the first item? Flip them. Now look at the next, and it's called a bubble search. The old days we used to write those all the time. Or if I want to search for an item in an array, I would write what's called a loop, and I'd say, okay, look at the first item. Is the first item what I'm looking for? If not, grab the next item until you run out. If you run out of items, it's not in the list, but if you find it, stop. Well, that's where the list comes in, because the list is a really cool item because it has sort feature built into it. It has a search feature built into it. And how do you declare a list? Well, what you're seeing on the screen right here is how I declare a list. If I wanted to store a whole bunch of dinosaur names, first of all, I don't have to tell it what the capacity of the list is going to be. I could store one item in this list, or I can store a million items in this list if I wanted to, and I don't have to give it a dimension. It will dynamically enlarge itself for me. So in this case, I'm creating a list. Okay, a list is a type, and it's going to be holding strings, and I'm going to call my list dinosaurs. And it's a little bit different on how I format it, because this is technically what we call an object. We'll talk about this a little bit later. So I'm telling it to create that list, and what this stuff at the end says is, because list is an object, when you create this new list, include all of the methods and all the properties that already exist with that list. That's what this part does over here. So include the sort and the search features of that list, those features that don't exist in the array. Okay, so how then would I add items to a list? Well, I could simply go back in and do dinosaurs.add and add in an item if I want to. Okay, or I could insert it in the list at a specific spot. So let's say that I've got 10 items in the list and I want to move the second item down. I can then say, let's put this, whatever this name of this animal is, the Compsognathus, at the second location. It would push everything down in there. So I can add items into it if I want to. Okay, I can also go back in and sort items. And it's going to sort alphabetically or numerically using this. So in this case, I would sort A to Z, and it would then take my entire list and it would sort it automatically. I can also go back in and say, where in this list, what's that numeric index of where Tyrannosaurus is at? And it will return back to me the numeric location of where Tyrannosaurus is. That's your search feature. If it doesn't return back an index, if it returns back a -1, that means that Tyrannosaurus does not exist in the list. Now, and if I want to remove the Tyrannosaurus, there's two different ways to do that. The one that I have on the screen here just simply says, I want to remove Tyrannosaurus. He will find the first Tyrannosaurus that exists in your list and delete it, because you could have more than one. So it's not going to remove all of them, it's just going to remove the one. There's another one here called remove at. And if I use remove at, then I can put a number in here and it will remove that index location. So if I knew that, like up here on this line, it said Tyrannosaurus came back and it was a location 4, I could come down and say dinosaurs.remove at 4, and it would have removed a Tyrannosaurus from that list. Let's go back in. I'm done with that basic lecture. Let's just really briefly take a look at the list object. So first thing I want is I might want this list to be accessible throughout my whole program. So if that's the case, what I'm going to do, and I'm just going to copy the code that I had here before, is I'm going to grab this code right here that we're seeing on the screen. I'm going to copy it, and let's go back here, and I'm going to paste it as a class level variable. Which means I want this list to be seen throughout all my methods wherever, because I might have a button that deletes and a button that adds, and I need to have access to dinosaurs everywhere. Good example of why I'd want this to be a class level. So now down here on the buttons, maybe what I want to do here is every time, let's get rid of this guy here, let's move this down, and instead of calling that text num1, let's call this text dino. Okay. Now, every time I hit calculate, what I want to do is I want to add to my list the dinosaur name that was added in that text box. So how would I do that? What I do is I'm going to do dinosaurs dot, oops, let's try that again. Dinosaurs, which is the list, dot, and if you look down in here, we're going to find an add method right there, add. And what I want to add in, I could very easily add, a stegosaurus if I wanted to in here. But I don't. I wanted to add whatever I type into that text box up above. So I'm going to say add in whatever is in text dinosaur.text. Okay? Just like that, and I close it out, just like that. Okay, so for right now, I'm going to put a stop over here so it stops every time I add a dinosaur in, and let's run it and see what happens. So I start the application up. Okay, I'm going to add in a let's get this right, S-A-U-R-U-S, don't know if that's spelled right, but we'll live with it. Click calculate. You should probably say add, so I add it. Okay, let's watch it add, because right now if I point to dinosaurs, notice it comes back and says count 0. It means there's no items in dinosaurs right now. So I'm going to step through this. Boom. I'm going to add what's in there. What is it going to add? It's going to add Tyrannosaurus. That's what's in the text box. Boom. It's now added it. Okay, so now I'm going to come back in here. I'm going to continue running. Okay, and I should wipe that out. Now I want to add in a stegosaurus. Stegosaurus. Don't know if that's spelled right, but that's okay. I click the button here. Now, if I click on dinosaurs now, notice it already knows that there's one dinosaur in there. If I open it up, there's my Tyrannosaurus at location 0. So now I'm going to step through this guy. Boom. Boom. And if I go back to dinosaurs now, there's two items in there, the Stegosaurus and a Tyrannosaurus. Okay. Now, if I wanted to, and I just stopped the program, by stopping the program, this bracket ended, the program ended, so that variable, even though it's class level, ceases to exist. I'll have to go back in and put those items back in again if I want to. But that's the add method I wanted to show you. And if I wanted to go back in, let's put another button here. Okay, and I think on that button, let's do add. Okay, and then over here, let's add another button in here. And I'm going to call this one button remove. Okay. And let's just see if we can make this work. On that button remove, let's put remove out here. And let's see if we can make this work. Okay. So I've got dinosaurs.add. Under here, I'm going to do dinosaurs.remove. And what do I want to remove? This time, if I click that button, I want to remove what's in that text box. So I'm not going to put strings in here. I'm going to put in here, I want to remove textdino.text. Okay? That should be a capital T. And let's rerun this. I'm going to run it right now as it is. We're just going to add a couple of them in here. And to keep this simple, because I can't think of enough dinosaur names, we're going to add in a dog, a cat, a horse, and a bird. And now before I do this, notice how my program's still running. I'm going to pause over here, right, like we did before. As the program's running, this is the great thing about the editor. And I'm going to jump back over here, and now I'm going to add in the horse. Okay, now let's go down here. Oops, I put it on the remove. Let's try that again. Wrong place. So now I want to add, I better add in a duck. I'm really creative today. Click add. Now, it hasn't added the duck in. There's duck. Let's step through it, and let's see what's in our list right now, in our dinosaurs list. It says there's 5 items. There's the 5 items that I typed in right here. Now what I want to do is I'm going to continue the running. Let's take that stop out. I'm going to continue it running. Okay. And what I want to do is, we have duck in here. Let's remove horse. Okay. I want to remove the horse. I've got to stop over here on the remove button. So let's watch what happens. Okay. So I'm sitting here. I'm telling it now, it hasn't run this line yet. I'm telling it I want to remove horse. Let's make sure horse is in the list. So I click here, and there's horse right there. It's at the second location right now. So now I'm going to step through this guy. Boom, boom, and it's finished. Now let's see if horse is gone. Now there's only 4 items. Oh, maybe I had 2 horses in there. Let's try that again. See if I messed up. Let's remove horse again. Now there's 3 items. I must have had horse in there more than once. It's only going to remove the very first horse it comes into, and it's going to stop at that point. So you'll see all the items I have. This is a really cool feature. I don't spend a lot of time on arrays like I used to, because nobody wants to use an array. You know, if I wanted to find an array, I would have had to look sequentially through every item and say, is 0th item a horse? Nope. Is the first item a horse? Second item a horse? Nope. Third item? Yes, it is. Then I would have to go back in and figure out how to remove that and move everything underneath it up. Lists make your life so much simpler, but the challenge with the list is the same problem you have with an array. An array can only be of one data type, so you can't go in a list and store in a list numbers and strings. You're either going to store strings or you're going to store numbers of a common data type. So I hope this made sense for you folks. I would recommend, if you didn't understand things, you come and talk to me about it, or you go back and you replay this lecture again. Otherwise, this was a long lecture.